With the set, there's a lot of concrete implementations, but the most popular one is hash set. There's also a tree set. There's enum set. There's a lot of sets. So there's a lot of concrete implementations, but the one we'll be using here is tree set. So you have to use a concrete implementation to initialize the set. We can have a set of names. Let's call this names set, or since we know that sets only store unique names, let's call these unique names. So these are very unique names, exclusive. So just like we used array list, you can initialize that with the new hash set, and you can add elements just like we did with the list. Most of the functions are available. Remember, again, Java collection framework. If all the collections extend collection interface or implement the collection interface, the interface types extend the collection interface. The concrete types implement that collection interface, which means everything declared in collection is available to us regardless of which collection we're using. So add is available, contains is available, remove is available. So all those functions we're exploring are available. The only difference is when the collection is specialized, you'll find some additional unique functions are added. Unique names, and let's add some unique names. So let's have Wayne, maybe. Let's have Jaden. Let's have Mila. So those are the names that we have. Of course, I'm adding them as if I'm using .of, but we'll get to that. And this capability is also available to sets, but for the sake of demonstration here, I'll just use the humble initialization method. So who did I have here? So we have Wayne, we have Jaden, we have Mila. Those are the values we have, and we can go ahead and print those names. So set of names, and this will be our unique names. So this is the set. If we run it, we'll see that we have Wayne, Mila, and Jaden. So let's assume we don't know that the set does not allow duplicates, or we accidentally add duplicates. So I'll add some duplicates here. Mila, I'll have Wayne again. Maybe add in another Wayne for good measure. So now we have Wayne, Jaden, Mila, Wayne. So let's see how the set handles it. So when I run it, you'll see I have Wayne, I have Mila, I have Jaden. Hey, what happened to all the other values? They were removed. Because with the set, if you add a value and it detects that that value already exists, it just ignores the value you're trying to add. So you're guaranteed of that uniqueness. The same way we have a guarantee of insertion order when we're adding values to a list, with the sets, we are guaranteed of the uniqueness. So there'll never be duplicates, at least not in this universe. So that is the guarantee you get from sets. And that is the main characteristic of sets that makes them different from lists. You can see in our list we're able to have duplicates, but in the set we are not able to have duplicates. So what can you do with a set? You can do everything that you can do with a list, except of course having duplicates. So you can iterate through a set the same way we did with list. You can call for each on a set, and that will give you an element, and you can do whatever you want with the element and print it. So for instance, here we can print E, and if we run that, we'll be able to see that the values are printed. Since I only have Wayne and Wayne duplicated, maybe let's have Jaden as well. You'll see we get Wayne, we get Jaden. So you can loop through the values You can also remove values. So you can remove values from the set. So you can call unique names dot remove and say let's remove Wayne, and that will remove Wayne from that set. So you see now we are on the left with Jaden. You can check the size of the set. You can basically do everything that you can do with any collection. So everything we're able to do with the list, we're able to do. So when talking about sets, if we go a bit theoretical into areas of like discrete math or logic or set theory, there is some things that sets are supposed to do. So sets have these things called unions and I think intersections. There's a third one that I can't remember. If anybody can remember it, type it on the chat. So there's unions, there's intersection. So union is if you have two sets, all the values that are in both sets can be, when they're combined, becomes a union. Intersection is all the values that are not present in that set. So let's try and do some union operation here. So let's have, I'll use integers for this. Just get rid of this printout. So let's create a set of integer. Call it group A. And this is a hash set. And in group A, we add some numbers. Let's have 1. Let's add 2. And let's add 3. Yeah, let's add 3. So we have 1, 2, 3 in group A. Let's have another set again of integers. Let's call this group B. And group B has group B. We add 4 in group B. Sorry, this is group B. Let's add 2, and let's also add in group B. Let's add 7. So if we are doing a union of these two sets, so if you want a union, the union of these two sets would be so 1 is not present here, 2 is present here, 3 is not present here. So the union of these sets will contain the value 2. Correct? If I'm wrong, correct me. So when you're doing intersection, you're looking for values that don't exist, are not common between the two sets. You can see 1 is not present here, so 1 would be in that intersection. 2 is present here, so that won't be. 3 is not present here, so 3 will be part of that. And then we have, so if we check this, 4 is not present here, so that will be part of that intersection. 4, and then we have 2 is present, 7 is not present. So I'm hoping I got this correct. If I got it wrong, somebody can unmute and correct me. Do a thumbs up if I got it right, or if my set theory is okay. Okay. So now let's see. So let's try and do a union. So if we were to only find the values that are common between, sorry, I'm getting some interference. So if we were to get values that are only unique to this, Is it somebody on the, oh, it's you, Dennis. Okay. I thought it was interference from my side. Yes, Dennis. Go ahead.
I think I've made a mistake, but I think it was in the second set. It is group B7, so the seventh element.
Oh, this one.
Group B.
Yeah. Thank you for that. I missed it. Thank you. Yeah. So okay. Thank you for that correction, Dennis. So now let's try and do a union. So if we wanted to create a set with only the values that are common between these two sets, how would we go about it? So there's one manual way we can do it. We can utilize this contains function. And what we can do is we can call group A and call dot contains. So contains, there's two variants. There's one where we're just checking one object, but there's another variant where you can pass a whole collection. So you can say group A dot contains all group B. And this will give us a Boolean if it contains all the values. So this won't be very useful. So this will just tell us whether all the values in group A are contained in group B. But in our case, we just want the value that is the same for these two collections. So one way we can do it is, remember here when we were trying to add a value that already exists. Was it here? So when you try to add Jaden again, so what happens is Jaden is not added because Jaden is already present in the list. So what we can do is in group A, we can call add all. Remember add all when we were covering lists. It functions kind of the same way here, except the uniqueness is maintained. So when we take 4, 2, 7, and we add them to 1, 2, 3, 4 and 7 are the ones which are going to be added. So at the end of the day, the collection that we will have will contain all the values in group A and all the values in group B that are not already present in group A. So I think that will give us the union. I think I got the union thing wrong. Okay, let's see what happens first before I conclude that this is not going to work. So group A, add all elements. In fact, to get this right, we can have another set. Let's call this set union. Hard set. And let's say union dot add all elements from group A. And then we can call union dot add all elements from group B. So let's see what union will contain at the end of this. So I'll do union dot for each. And just for convenience sake, let's have that union label at the top here so that we know we are printing a union. So this will be element. And since they are strings, I can just do io.println. Okay, io.println and print the element. Of course, it's suggesting something here that we'll cover in functional programming, but we'll be able to use that now. So when I do that, I would like this to be in one line so that it's easier to see. I'll just do a plain union like that, so that they're in like one nice box like this. Yes, this is much easier to visualize. So we have union, and union has 1, 2, 3, 4, 7. So the union has So the union of A and B has all the elements in A and all the elements in B that are not unique values. So I think I got this union thing wrong. Let me Google it. Set union. Union combines all elements from two or more sets into a single new set. So I think this one combines all the elements as long as the final set is unique. So if we have, and pardon me here, so if you have group A, or let me say set A, and set A contains 1, 2, 3, 1, 2, 3, and then we have set B, and set B contains 4, 2, 7. Yeah, 4 to 7, yes. 4, 2, and 7. When we do a union, it will have 1, 2, and 3. And since 2 is duplicate, 2 won't be duplicated in the union. Instead, it will be 1, 2, 3, and then we'll get the 4, and we'll get the 7. So if 7 already existed here, we'll be able to just have 1, 7 at the end. Since 2 already exists here, it won't be duplicated. So I think this will form the union. If you look at the diagram, I can put that diagram. Union. Shared better. Okay, so union. Okay, actually, union is, I was right the first time. So union is the values that are shared between the sets. So this will be the union. So in fact, union should be, so union here will be 2. So the values that are shared between them. Let's see what this other one is. I think that might be intersection. Let me see. So this just covers union. Let's look at intersection. So if we look at intersection, oh wait, this is so confusing. So actually, going back to union. So union is all the elements in both the list. So this is the union. So it's all the elements in both of the sets. Then intersection is now what I was referring to with the 2. So if you look at intersection, so intersection is only the element that is shared between this set and this set. So the intersection. So the intersection here is, in fact, so intersection is only the elements that are shared here. Correct? Intersection. Yeah, so like if we have 1, 2, 3, then intersection 2, 3, 4. So we end up with 2, 3 because 2, 3 are the only ones that are shared here. So the intersection here would be 2. Then the union, going back to the other one. So the union, let's see an example. Union. Okay, they don't have a similar example like the one we used. So okay, so if you have A, which has 1, 3, 5, 7, and B, which has 2, 3, let's zoom in a bit. If you have A, which has 1, 3, 5, 7, and B, which has 1, 2, 4, 6, 7, then A union B will be 1, it will be 2, 3, of course, 4, 5, 6, and 7. So it will have all the elements that are contained between the two sets. So this will be the union. So this is union, and intersection is only the element that is shared between the two sets. So what we are creating here when we say add all, this is intersection, not union. So that is the intersection set that's shared between the two. And if we print it, but let's try and print it the way we have it here. So let's say we have group A, and group A is group A, and we have our group B, let's say B, and B is group B. So union, so this is intersection. So intersection equals this intersection set. That will be the intersection. I spelled this wrong. Intersection, yes. So if you take A, I think they'll be printed correctly, so you don't even need to modify it. So if we have A, which is 1, 2, 3, and you have B, which is 2, 4, 7, the intersection is 1, 2, 3, 4, 7. So it has all the values. Now so that is intersection. The union. Wait, am I again confusing these things? So union is the one that combines them. Intersection looks for the. Okay, so this is union. It's like a puzzle. So this is union. So union combines them. Intersection looks for the unique value. So so this would be if you have 1, 2, 3, and you have 2, 4, 7. The union would be 1, 2, 3, 4, 7. So this would be the union. When it comes to intersection, it would be let me reuse this so that we don't have to reprint it. So if you have A, we have B, the intersection should be the intersection set that we get. So in fact, this is the union set. Union. So now let's try and get intersection. So intersection is the element that is unique to each set. So you can find it in oh wait, let me make sure I got that correctly. Set intersection. So if we have 1, 2, 3, and then intersection with 2, 3, 4, the intersection will be 2, 3. So it's the values that are present in both sets, not all the values from both sets combined. So this is values that are present in both sets. So now let's see how we can obtain that. So there's this function that's available in collections. I hope it will help us. And the function is called retain all. I'm hoping it will help us achieve the effect that we are trying to achieve. And if we call group A dot retain all, let's look at its documentation. So what does retain all do? So with retain all, so retains only the elements in this set that are contained in the specified collection. So it's actually able to check if the elements in the set we are passing in is contained in that set, then it will retain it as a value. I think otherwise it will be removed. So it retains only elements in this set that are contained in the specified collection. In other words, removes from the set all of its elements that are not contained in the specified collection. So I think this will help us achieve the thing. So now we can have our intersection set. So we can have a set here, integer, and call it intersection. is equals to new hash set, and so we can call group A dot retain all group B, and so that will modify that that group A. Perhaps we can call it on the set itself. Maybe we can call it on the set. So if we call intersection dot retain all group A, and then intersection dot retain all group B, then we can go ahead and print that intersection. That's a problem on empty collection. Okay, so retain all. So this intersection set needs to have all the values first. So it needs to be a union at the beginning, and then we do retain all on it. So you can call add all, and we add all elements from group A, and then add all elements from group B. So before we call retain, then if I'm correct about this. So we add all the elements that we have, and then we call retain all. I don't know how effective that will be. I think we might need to begin with a single list. Okay, let's try this strategy first. Let's see if we get the intersection. Let's see what we get anyways. So I'll just run it. So we see we have 1, 2, 3, and then we have 2, 4, 7. A union is that. We have 1, 2, 3, we have 2, 4, 7, intersection is 2. So actually it gave us the effect that we were hoping for. So we would get the union and intersection. Just curious, what if we did add all of them at the beginning? Okay, we still get the same effect. So you can add all of them or add at least one. I think you need to have at least one before you can call retain. But you can see the purpose of retain all. It will go in and check whether that element we are trying to add is unique to that set. If it is unique to that set, it is not added. If it is common between the set we are trying to add and the set that we are adding to, then the value is retained. So for this operation to exist, you must already have as a union set. Essentially, what we are using for it is a union set, because if we're adding all the elements, this will be a union set before we call retain all on it to make it an intersection. Okay, that was an interesting experiment. So you can do set operations, as you can see. There's a third set operation that I can't remember. Yeah, it's called difference. So there's this set operation called difference that you can also do, except it's a bit more complicated. I don't know if I still have you guys. Yes, Louis. We are kind of doing discrete math. Even me, I'd forgotten a bit of discrete math here, so it has become a bit puzzling. Yeah, but we've done union, we've done intersection. Let's see what this difference is. So if we go to sets difference, they have a nice simple example like the other one. There isn't even a Wikipedia for it. Wikipedia. Yeah, set difference, yes. Oh, okay. So relative complement, I don't know now if relative complement is actually the set difference. Okay, but yeah, I think it goes into some comparison here. So if I can read this, I think this relative complement is the set difference. So if A and B are sets, then the relative complement of A in B, also termed the set difference, yes, of B and A, is the set of elements in B but not in A. Yes. So the elements that are in B but are not present in A. that will becomes the difference between A and B. And I think it can also be in reverse, the elements in A that are not present in B. So that is the operation. It's denoted with this B slash A is equals to X, all members in X, such that X does not have the relationship with A. So the element X is not in A. So that is a value. So I think what that means is, in fact, there's a clear example here. So we have 1, 2, 3. The difference between this set and this set is 1, because 1 is only available in this set but is not available in this set. The difference between this set and this set is 4, because 4 is available in this set but is not available in this other set. So I wonder how we can achieve that here. In essence, what we'll be looking for is, for instance, if we are comparing B to A, the difference will be, so 4 is not available here, so 4 would qualify, 2 is available, and then 7 is not available in this. So if you're comparing B to A, the difference would be 4, 7. So using the add all and retain all functions, I wonder how, maybe a remove all function would give us that effect. Any suggestions how we can get a set difference? Okay, we already beyond time, so let me give this one attempt. If it doesn't work, I'll do my research and then I will try it out again in the next session. So let me try and give it an attempt. So if you have a set of integers, and this is difference, the diff, and of course it's a high set, and in this diff you should contain the difference between group A and group B. So I'm going to attempt to subtract group B from group A. So which function can help us here? So we can take group A, but remove all group B. And since this removal function doesn't give us the value, we can start by populating the difference with group A. And then now when we do the removal, we can do the removal on the diff itself. So we can add to group A, and then after we added, we call group A dot removal group B. So it should remove all the values in group A that are present in group B. So the way we are subtracting, so we have group A, then we have group B. So we are subtracting group B from group A, I believe. Let me just print that out, see what we get. So group A, and this is diff, and then we do diff. So that's the diff set. I'm already seeing the IDE doesn't like what I'm doing here, but I'll just go ahead and run it, just see what we get. So group A is 1, 2, 3. Group B is 2, 4, 7. The difference is 1 and 3. 1 is not here, 3 is not here. Yeah. So this gives us the difference. So we have union, we have difference, and we have intersection, and we have difference. So this is set operations. I don't think there's a fourth set operation. If there is, I'm not aware of it. So it's unions, intersections, and difference. And this becomes very important if you are like writing applications and you want a super optimized way of, for instance, finding students who have a unique grade, finding students who share the grade. So if you have 100 students who have B plain, you have 1,000 students who have A, you have 700 students who have C, you can use these set operations to create unique collections that contain all the students that share the same grade without looking at whether it's A, B, or C. So interesting stuff, and this can become useful, very useful when you're writing your own software applications. So this has been awesome. I've stretched way beyond the time that was allotted to this session. And I think I've run through all the patients that you guys have. And maybe the only thing I can ask is if there are any questions before we close it. Recap, we've done list.off, we've done list iterator, we've done we've looked at Java 8 for each, we've looked at Java 9, list.off, and like I mentioned, the same way in Java 9, you can use list.off, you can also use set.off. So I can create a set here. Let me call it set x. You can do set.off and just pass in the values you want to pass. So if it contains numbers, you can just do that. And of course, it will enforce uniqueness and yeah. In fact, I think this will automatically throw an exception. Yes? Yes, Dennis?
I was requesting if you could like briefly do a small recap on the difference. Like you have added the set A, then removed set B. If you could just do a small recap on the difference.
So let me do a recap on this, but you guys see this. So just know that the same way you can do list.off, you can do set.off and any other collection. So you don't have to always initialize with the new asset, except if you do that, it's immutable. So if somebody tries to modify it, your program will crash. So you should be prepared for that. Okay, so let's recap this. So we have two sets here. We have set A and we have set B. Now, set A has the elements 1, 2, 3. Set B has elements 4, 2, 7. And if we print those two sets, just comment this out before. So if we print these two sets, so if we can do io.println to print the first set, and call this, of course, set A. And we have set B. So maybe I should have called them set A, set B. It would have already been nice. So if we print them, we have set A, 1, 2, 3, set B, 2, 3, 4. Now, when you are doing set theory, there's 3 operations you can do. One of them is union. The other is intersection. And the third one, as we saw, is difference. So a union of set A and set B, because set A, so A here, set A is contains the values 1, 2, and 3, and set B, so if we do a union of set A and set B here contains the values 4, 2, and 7. The union of set A and set B will be all the values that are in A and all the values that are in B that are not duplicates. So if this set A, let's assume, had 3, and it had this set B had maybe 4, these duplicate elements will not be duplicated in the final set. So the union will have all the unique values from set A and set B. So let me just print it out. So that will be 1, 2, 3, 4, 4, and 7. So it will have 1, 2, 3, 4, and 7 because 2 is already on this set. So this will be the union of set A and set B. When it comes to intersection, so let's see how we achieve the union first. So the way we achieve the union is we can take, so what we're looking for is a combination of this. So since we know if you try to add an element in a set that is already contained in that set, the element will be skipped. It won't be added because the set will enforce uniqueness. All the elements in the set have to be unique. We can utilize that to achieve this union theory. So we can get a set here, and we call this set union. And of course, we can initialize it with high set. And what we can do with this set is we can say union dot add all elements from group A. So it will add all the values from group A. And now when we call union dot add all elements from group B, while adding the elements from group B, it will ensure that there are no duplicates while adding it. So if group B, like I showed earlier, contained 3 again or contained 2 again, it won't be repeated. In a regular list, that would be repeated, but it won't be repeated. But at the end of the day, for all the unique values in both sets, they'll be available in the union set. So now if we print this set, do I.println, and say union, in fact, let's try and print it the same way we had done earlier. So this is set A, which is group A, and set B, which is our group B, and the union is our union. So if we print that, we will see that we get, so our set A has 1, 2, 3, set B has 2, 4, 7. So if we do a union of 1, 2, 3, and 2, 4, 7, we get 1, 2, 3, 4, 7. So 1, 2, 3, 4, 7. So 2 is not repeated, although it's present on both sets. So that's how we get union. Now, when it comes to intersection, you can create a set. So first of all, let's define what intersection is. So we have these two sets. So we have these two sets. We have set A, 1, 2, 3, and set B, and we are getting the intersection between set A and set B. So this has 1, 2, 3, this has 4 to 7. The intersection is the element that exists between this set and this set. So the elements that appear on both sets. And the element that appears in these two sets is only 2, because 1 is only here, it's not here. 3 is only here, it's not here. 7 is only on this set B, it's not in this set A. 4 is only in set B, it's not in set A. So 2 is here and it's also here. So the intersection between these two sets would be 2. The elements that are shared between the two sets. So programmatically, how do we achieve this? So essentially, we are looking for elements that exist in both. So this is where we utilize a function in collection framework called retain all. So what retain all does is, I think we looked at the documentation for it, but what it does is, if it finds the value in set A, so let's say we are adding set A to set B. If it adds this 1 to set B and finds that this value is not present here, it will not add it. So it's looking for common values. So if it wants to add 2 and it finds that 2 is also present here, it will keep it. If it wants to add 3 and finds that 3 is not present here, it won't add it. So let's just try that and see. So if we create our own set here of integer and call this intersection, of course, hash set is what we are using. And if we go ahead and, so we'll need to begin with some value. So we can add group A to it. And we can say intersection dot retain all in group B. And now if we print it the same way, if we print that, So this will be intersection between set A and set B. So what should happen is, so we've added group A to begin the operation. When we call retain all group B, this set will attempt to check whether the values in group B, while it's adding the elements, it will check each value. If the value already exists in group A, it will retain it. If it doesn't exist, it will either be removed or not added, I believe. I hope I got that right. Let's see. I might have missed something there, but let's see. Okay, so union, still printing intersection. So yeah, so this should be intersection. So let me scroll to it so that we see it even as we do it. So we'll see that 1, 2, 3, 2, 4, 7. When you do this retain all operation, which is taking these values and attempting to add only the common values from this and this, it will find only 2 is common between them, and that will form our intersection value. I hope that's correct. Yeah. So intersection only contains 2. So I think Dennis was more concerned with difference. So let's see if we can get difference. So with the difference, if we have this set, these 2 sets, so we have set A, which has 1, 2, 3, and we're looking for difference between set A and set B. The difference between set A and set B, so let's say, okay, so we have 1, 2, 3, we have 4 to 7. So think of this as subtraction. So if you are subtracting 4 to 7 from 1 to 3, what will be left with? So since 4 is not present in A, 4 will be retained. Since 2 is present in A, 2 will be, it's a common value, so it won't be retained. Since 7 is not present here, 7 will be retained. So I think at the end of it, we should remain with 4, 7, yes. So at the end of it, we should remain with 4, 7. So how do we achieve this subtraction? So remember, I'm subtracting this from this. You can also do it in reverse, and I believe since it's subtraction, you'll end up with the different values. So we can put that to the test. It might be the same value either way. But when we're subtracting B from set A, we should be left with 4 and 7, because 4 and 7 are the only values that are present in B but not present in A. 2 is shared. So if you're subtracting A from B, we should be left with 1 and 3, because 1 and 3 are the only values present in A but not present in B. And the way we achieve that is can create first the set. We first create the set, and the set here is difference is equals to new hash set, of course. And for us to do the subtraction, first we add all the values. So div add all group A, and then div. So at first this set needs to contain both values, group A and group B. And then now we can utilize remove all. So you can do div dot remove all group B. I think that's how we get it. So if we remove all group B, because in this add all operation, the duplicates will have already been removed. So now when we call again remove all group B, so remove all, this will be 4 to 7, remove all 4 to 7 from here. I think that will help us to get the difference. Although I'm not completely sure, to be honest. Let's see how this removal behaves. remove from this set all of its elements that are contained in the specified collection. If the specified collection is also a set, this operation effectively modifies this set so that its value is the asymmetric set difference. In fact, actually it's the documentation of the two sets. So since it will check that it's a set, we might not need to add group B first. So we can just take group B and subtract it, or remove it from group A. If this was a list, this would be a normal removal operation, but since it's a set, it's going to do a subtract operation instead. So it will do a set subtraction. It will not do a regular remove. That's why it was confusing me a bit. So it will not do a regular remove, instead it's going to attempt to do a set subtraction. And now if we run it, so this is div, and that should be the div set. If we run that, we'll see, so set A has 1, 2, 3, set B has 2, 4, 7. The difference is 1 and 3. So it has subtracted, okay, this has worked in reverse. let me see what I added first. So I added group A and then I subtracted group B. So if we add group A, then we subtract group B, we get 1, 3, because 1 and 3 are the only values that are not present in group B. But also we can do a reverse. If we add group B and we subtract group A, I think we should get the reverse, which is 1, 4, if I'm not wrong. Okay, so this still gives me 1, 3. Group A. Okay, I did not really reverse it. So
you've done it. Did then all instead
of. Sorry, can you say that again?
Let's see, because that's what it's. Difference is what was challenging to me.
Yeah, even me, it's a bit puzzling. So let's see. So yeah, so now if we start with group B, so if we take group B and we subtract group A from group B, we end up with 4 and 7, because 4 is in group B but it's not in group A, and 7 is in group B and it's not in group A. But if we start with group A and we subtract it from group B, in fact, let's have those as separate operations. So let's have this one as group A, then we subtract group B, and I'll try and, oh wait, I'm changing this thing in the wrong place. Okay, so I should be changing it here. So in fact, let me try and write it in a way that, so A minus, because we are doing a subtraction, minus A minus B, then the difference. And here we start with A. What is that? So we start with A. This is group A. And we subtract group A from group B. So A minus B. And then let's do a different one where we do the opposite. Let's do, I'll call this div2, and div2 there. So let's take B minus A, so the opposite. And this is B, this is A. So now we are adding group B, and then we are subtracting it from group A. So let's see what we get. So I think this will expose the difference between the two. So here we are adding group A, and then we are subtracting group B from group A. Here we are adding group B, and we are subtracting group A from group B. So it's in reverse, B minus, so this is A minus B, and this is B minus A, or reverse. Okay, let's see it. Let's see it. Okay, so A minus B. So the difference is 1, 3. Yeah, I think this might make sense. So if you subtract A from B, you have 1 here that doesn't exist here, comes part of it, a part of it. 2 already exists in both, so it won't be part of the list. Then 3 here does not exist here, so it becomes part of the list. Okay, if you're subtracting B from A, you have 2 here that exists in both, so it won't be in the final list. You have 4 here that doesn't exist here, so it will be part of the list, part of the set. You have 7 here that doesn't exist on A, so it will be part of the set. I think when written like this, it might be clear. Dennis.
Yeah, it's clear now.
Yeah, but the main thing to remember is the way you're able to achieve that is by remembering that remove all does not behave the same way it would if you are using a set. If you're using a set, it does the asymmetric difference, so it actually does that subtraction for you. If it's a regular list, of course, it will do the regular removal, but if it's a set, it will behave differently. It will try to implement a symmetric difference so that it gives you this effect. So this, like I was saying, this is very important when you're writing software because just out of the top of my head, I told you about that example where you have KCSE results are out and you want to create sets that have students based on their grade without doing a for loop and going through every student and comparing, is this the same grade as this? Is this the same grade as this? You can just do a set difference or a union or an intersection, and you're able to arrange that data really nicely, and you do some nice data analysis that forms some beautiful charts for people to look at. Okay, so this has been awesome. Any more comments or questions regarding sets or the stuff that we covered? Let's see if there is a message. Solo is saying removal maybe. Yeah, it turns out removal actually solved at least that part. There's a part where we were able to solve with removal. Yes. Thank you for the, in fact, the difference. Thank you for the suggestion. So it solves the difference issue. No worries. But there's a recording, like you can see on the pinned message. So you'll find a recording for this session. So even if you joined late, no problem. Just make sure you subscribe to that channel if you haven't. Yeah. Any questions or comments? Okay. I think this has been awesome. We've learned plenty, and even me, I've been able to brush up on my set theory knowledge. So it was really good to learn some more set theory. So of course, we are still not done with collections. Since we were able to do sets, next session, we should be on Thursday, we will look at maps.